Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We are live today at Roy W. Loudon Elementary, home of the Leopards, and we're here to...
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Devin. Hey, thank you so much for being here this afternoon. Here in the Bakersfield area, the rains are coming down, so you've got two jobs today. One, stay dry, and two, join us. We've got an action-packed hour. We're going to be joining the folks over at Loudon Elementary a little bit later on in the show. We've got a guest coming in studio to help us out from the 4th grade today, and the only part missing is you. So please go ahead and join us in the Bakersfield area. Call us with your homework problems. We'll help you out with them at 636-4357. And hey, we don't want to exclude the folks in the San Luis Obispo area. You are welcome as well. Please join us toll free, mind you, at 1-866-636-6284. Go ahead and feel free to email us your questions. We'll respond to them live on the air here at dothemath@kern.org. And of course, as always, you can watch us online at dothemathonline.net. And if you're on social media, if you've got Facebook at the ready, Instagram over on your phone, Twitter with your thumbs to the man, you've got it. Check us out on YouTube. We are there, and we'd love for you to join us today.
You have a Facebook page?
Absolutely. I was one of the first adopters when it was thefacebook.net out at Boston when it was only college kids.
So you've got a lot of information on there then, right?
I used it to get to the information. They let you get into the libraries back then.
Because Scott was saying how he has one also, and he recently put like his second thing on there from the show the other day.
Oh, wow.
So I was just curious as if you were a novice or you are
I would say I'm a legacy.
well-versed in it now, so from the very beginning. All right, well, as Devin said, we do have phone tutors available until 5:30, as we do most Tuesdays and Wednesdays throughout the regular school year. And we have our very special guest in studio, but before we get to any of that, let's first take a look at today's Math in the News. So in high school, did you partake in any athletic events?
Oh gosh, certainly.
So what kind of sports did you play?
So at Staten Island Academy, it was one of these schools where there's only 24 kids in the graduating class. So you showed up,
large school,
and you were there. Everybody in this school got their own page in the yearbook. So I got to do baseball, I got to do cross country, I did soccer as well. Captain of the cross country team my senior year, finished in last place in my last race. They thought I was
But
lost.
you were still captain.
Well, not after that race.
Well, it's a good thing it was the last race
That's
then,
right. Make it count.
Well, one of the things that I partook in was track and field events.
Yes.
And not events, I did events.
Events.
So
Singular.
I did 400, or 440, because it's 400 now.
Yes.
But when we were growing up, it was 440 yards instead of the 400 meter. And I always thought that the kid that did the pole vault was just a little bit off. And all of the other kids from the other high schools that pole vaulted, it was like, you guys are just a little bit off. I mean, because of what it takes to do the pole vault.
There's a whole other mindset behind throwing yourself 18, 19 feet in the air and just trusting that you're going to come down okay.
And that would be an accomplishment if you
That's
were getting
world
that
class,
high.
yeah.
But anyway, there was an article in a publication I read the other day about a famous pole vaulter, all right? This guy's name is Sergei Bubka. Now, we can just see the overall from the beginning to the end once you successfully make it over the bar right there.
So here's the technique, from ground to air, and then hopefully a safe landing.
And this right here is the part where you are vaulting yourself up using that pole. So I figured let's get some professionals in here and see what they look like
here today,
actually
phenomenal.
doing it.
Do we have the space for this? Are we going to make it work?
Yeah, if they were going to pole vault, we need some other
I feel like we
adjustments
need
to
some
the ceilings
renovation
in
in here to raise.
So here are some photos of people that know what they're doing and doing it correctly. Now here's our boy.
All right.
So we're going to leave Sergey up here for a little while. A Ukrainian man. And he would go to Italy and compete in international track and field events. All right. And he would break the record every time he went. Okay. Now he did this only because he wanted to break a record, but that wasn't even the main reason.
Okay.
To make money at it.
Well, yeah.
Now we know that athletes make a lot of money. Track and field probably not as much as other sports. Not
Internationally,
nearly.
though,
They
it is
make
close.
some nice money.
Absolutely.
But many athletes get a bonus from their sponsor when they win. So if you win, that's great. Now he was like, all right, I'm going to win, but if I don't break the record, I'm not going to get any money.
Right.
Okay. So what he did is his sponsor was Nike, and he set a mark of 6.08 meters. And we know that a meter's a little bit longer than a yard.
Right.
So you're talking over 18 feet.
If we do
Right?
some
So
rates in
that's
our
what
head,
you were
yeah,
talking about.
a little
So,
more than
18, so
18.
you're talking upwards of 20 feet, something like that. So Sergey, what he would do is from 1991 to 1994, he set it at 6.08. So the next year, he would only have it go up to 6.09. Therefore, he could break the record,
Every single time.
even though he
competes.
could go higher.
Absolutely.
The next year, he would go to 6.10. The next year, because you can set the mark at wherever you want.
He could have very
in
easily
pole
gone up
vaulting.
to like 6.2, 6.5 right off the bat, but he knows that he's the only one in the world that's going to be able to clear
He's
this.
doing this, and he's the record holder, and he held the record for a long time. So that is what he was doing, only going up by 1/100th of a meter every single time.
Just
So I
enough
thought
excellence to
an
perform.
excellent opportunity to talk about the metric system once again.
Here we go.
So we can see that if he's going up 1/100th, a centimeter, right, every single time, he's getting himself, now here's what he was getting paid every time he did this, between $40,000 and $100,000 as the bonus for setting the world record. Now he's already getting whatever his sponsor gives him, his corporate sponsors, making sure he's taken care of as far as training and things like that. Here at the end, other than what he normally received, he received $600,000 in bonuses just for pole vaulting. So that, simply by using the metric system, we can see that it's an easy system to use only by moving the decimal point back and forth instead of doing conversions like we do with the customary units that most other people are accustomed to. And that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30. In studio with us right now, we have Jaidenelle. How are you today?
Good.
What school do you go to and what grade are you in?
I go to Old River Elementary School and I'm in 4th grade.
Fourth grade going pretty well?
Yeah.
Let me ask you this. Have you ever seen anything like this, the metric system? Have you guys used the metric system at all?
No.
Okay. Do you know how decimal points work?
Sort of.
How do you know decimal points? Like, where have you seen them or how have you used them yet in school?
In fractions.
Okay, so in fractions, so you can convert a fraction into a decimal.
Yeah.
All right. How about money?
Um,
Do you have decimal points in money?
yeah.
Right, like something that costs $2.15, right? So you're pretty familiar with decimals. And if you haven't started yet with the metric system in school, guess what?
What?
You're going too soon. But what are you working on right now in school?
Fractions and long division.
Which one do you like better?
Fractions.
You like fractions better? Good. Well, then we're going to do some long division first. Okay. Head on over to the board. We'll have you do a long division problem. Now, this is one off of your math homework, and it has 92 divided by 6.
So if we're dividing 92 by 6, and we use the traditional long division bracket here, you know, what's really interesting about 4th grade is that there's a lot of different ways you can approach it. Long division is one way. And let's take a look at how you've been working on that. So what is the first thing you would do here?
Okay, so the first thing you would do is 6, so you would ask yourself 9, how 6 goes into 9.
So what we're really saying, if you think about what 92 really is, that 9 doesn't just represent a 9. What we're really asking ourselves is, how many groups of 6 do we want to start off fitting into 9 tens, or 90? So out of those 90, how many groups of 6 could we start off by putting in here?
You can put 1 6 into.
So what that really represents is we're going to have one group of 6 out of 9 tens. So we can go ahead and put that 1 up here. And now what we're going to do is represent how many tens that one group of 6 represents. So how would we do that? We have 1, 6. How many group of tens are in one group of 6 tens?
2.
Well, we usually will multiply with the structure of long division, right? So we have 1 times 6, and what does that leave us with?
6.
6. So with this structure, we want to see how much of the 92 is remaining now that we're taking away one group of 6 tens, which is essentially 60. So we would subtract here from the tens column, and that leaves us with how many?
3.
3. Now, we do have 3 tens remaining, but we also have some 1s we can also throw in there, right?
Yeah.
So let's go ahead and bring our 1s down. Now we're considering how many 6s can fit into 32. And for this sake, we're talking about 32 groups of 1. So how many groups of 6 can fit into 32 1s? Or what can we guess that we can try?
4.
Let's try 4. I think that's really helpful. Let me go ahead and just kind of bring this a little bit up so we have some more space to work with, okay? So if we have if we have 4 groups of 6, how much do we have then?
24.
24. So let's go ahead and subtract 24 and find out if we have any remaining, okay? So when we subtract 32 from 24, how much is left? Just want to get that 4 up there.
8.
8. 32 minus 24 is 8. Now this brings us to an interesting situation. We have some decisions to make. We have 14 groups of 6 that we know fit into 92. And there's still 8 left. I'm just going to take this 14. I'm just going to put it over here for a moment. Can we fit any more groups of 6 into this 8 that we still have left over? How many more 6s can we fit into this 8?
1.
1. So let's do that. Let's take one more group of 6 away from 8. And when we do that, let's look at how much we'll have left. So when we subtract 6 from 8, we'll have how many left?
2.
2. Now, we had one more group of 6 that we brought in. So we have 14 groups of 6 and 1 group of 6. So that means we have 15 groups of 6. But we have 2 left over. What can we do with that 2?
We can use that as a remainder.
As a remainder. And what that means is we don't have enough to create a new group of 6. We have 2 out of 6. And I know a lot of teachers like to focus on the idea of putting the remainder off to the side. So representing this as 15 and remainder 2. But the answer itself doesn't give us any information about the size of each of those groups. So what mathematicians love to do with the remainder is actually represented as, like you mentioned you enjoyed before, a fraction. Because if we think about this, if we have 2 out of 6 remaining, then that's 2/6. So we have 15 and 2/6 when we divide 92 by 6. Now we can simplify this fraction. We don't always need to. But this represents the amount of 6s that we have in 92. We can have 15 groups of 6 with 2 out of that last 6 left over.
There you go. Nicely done with the first problem right there. Hey, we do have phone tutors available until 5:30 this afternoon, and right now we have an opportunity to go out and about. We'll visit with Marylou.
We are back live at Roy W. Loudon Elementary School, ACE's after-school program. And Mike, you were talking about track earlier, and we have a couple sprinters in the room. We have some students who did high jump. We have some long jumpers. And myself, I did the hurdles. So yeah, we kind of enjoy it, don't we? Okay, so earlier we were talking about, what is this X called, everybody? A what? Starts with a V? I heard it. What? A variable. We were talking about variables, which are what? I need one person to tell me what a variable is.
The number to add to the equation.
Right, a missing number, yes? Okay, so it's the missing number. So we did this problem earlier, 3 plus x equals 12, and what was x, everybody?
9.
It was 9. Then I added this, another variable, and I asked you guys to think about this. So again, now I have two variables. Can those variables be the same number?
No.
No. Okay, so what's our thinking? Some hands. What are our thinking? What do you think?
Wait, can we see the
Yeah.
answer?
Tell me what you got.
3 plus 3 plus 6.
Okay, the first three, which variable does that represent? Is that your y?
Yeah.
Okay. If that's your y, then the 6 has to represent what?
The x.
The x. Okay. Does somebody else come up with something different?
I came up with 8 and 1.
8 and 1. So is 8 your y? Okay, so 8 plus 3 we know is 11, plus 1 is 12. Did anybody else come up with something different back there in the corner?
Oh, I came up with 7 as y and 2 as x.
So we have a couple different answers. Is that okay?
Yes.
Why? Why is that okay to come up with different answers?
Because they all equal the same thing.
Exactly. They all equal the same thing, don't they? Okay, so taking this information, think about this, all right? Go ahead and erase your boards. Here we go. Here's our problem. Our problem is a teacher wanted to know the ages of Susan and Juan. She knew that Ricky was 12 years old. What are the ages of Susan and Juan if the total age of the three students is 22? What important information do we need to underline?
Susan and Juan.
The ages are what?
The ages of Susan and Juan.
Okay. Is that what we need to find out? Is that what it's asking us to find out?
Yes.
Okay. It's asking us to find out that. What else do we see?
We have to we can also underline total age of the 3 students is 22.
Exactly. So our total age is 22. There's one more other important aspect.
The teacher knew that Ricky was 12 years old.
Okay. So now again, I want you guys to think about this. And I want you to think about this word problem. And I'd like you to make me an equation using x and y as variables to represent Susan and Juan. Which one do you want for Susan, x or y? Y. So Susan's going to be our y variable. That means Juan's going to be our
X.
Write me an equation, and then after the equation, I want you to solve it. Talk with your groups. Go. Let's find out what they're thinking. So what's our plan here? What do you guys think? What do you think our equation should look like? Think about it. What variables are we using? Okay, and what number do we know for sure that what age do we have? What? Well, that's what, is that in age or is that what it totals? What is 22? In total, okay. So what age is given to us? 12. Okay, think about that and keep Righty. Okay, so you guys have an equation over here. Explain, what equation did you come up with?
So we put y plus 12 plus x, right?
Right?
So
Equals.
equals 22.
22.
Okay. So what do you guys think, where you're going to go to next? You have your equation. Where can you go next?
Try to figure out these two numbers.
Okay.
So
X.
it'll be 12
Okay, keep going. Does anybody have any numbers that they came up with? Okay, over here. What do you guys think? So first tell us what your equation is.
Our equation is y plus x plus 12 equals 22. So first we need to subtract 22 from 12, and you're left with 10. Then we divide it by 2 equals 5.
Okay, but remember, can x and y be the same number?
No.
No, so how can we change these numbers to equal 10?
6 and 4.
Try it. Let's see. See if that equals 22. Yeah. So change the two fives to what numbers did you say again?
6 and 4.
Okay. Does that equal 22?
Yeah.
Yes? Okay. Now I want you to try to come up with two more numbers. Okay, did anybody else get two more numbers? This group right here, real quick. What did you come up with for x?
I came up with 7 and 3.
7 and 3. And 7 and 3 equals what?
22. Wait, 10.
Plus 12 is?
22.
Awesome. Okay, as they continue to work, we're going to send it back to the studio, and we'll come back in just a little bit.
Thanks for that, Marylou. Nice to see the kids working on that problem. We do have phone tutors available until 5:30. We have 4th grade student Jaidenelle in studio with us right now, working on some long division. She solved one problem, but now we're going to take a look at another problem a couple of different ways. All right, take it away.
So the problem that we've been tasked with right now is 75 divided by 2. And we had a really interesting conversation about how there's a lot of different ways to represent that or make sense of this. There's the traditional expression where you represent it across. And then, Jaidenelle, you have the method in front of you that you've been working with, long division. Now, what do you notice students do when they have to read this out loud for the first time? Are there some mistakes they make in reading that?
Yeah.
How do they read that sometimes?
275.
Yeah, they'll say 2 divided by 75. One of the things that students struggle with a lot is reading this differently. So it's almost like we want to put some sort of phrase that that long division bracket can represent. So 2 can go into 75 a certain number of times. And so that's really what we're trying to figure out with division. In fact, you can kind of look at it like a multiplication and addition based expression. So that's kind of what we have here on the left side. 2 times some number plus another number is going to equal 75. And so there's a few different ways we can approach this. We can look at it through the lens of long division, which we'll start because that seems to be the path in which we're headed. So let's work on that. Go ahead and work on 2 divided by, I'm sorry, I almost did it myself. Did you hear that? Oh, cut the tape, that didn't happen. How many times can we get 2 into 75? Or how many groups of 2 are in 75?
10.
So you have something interesting here. What you're thinking of is how many of a certain value I can start off with and work up to 75. So let me try that. I'm going to work over here if that's okay. You said 10. So we're thinking about 2 groups of 10. If I have 2 groups of 10, what does that equal?
20.
20. Is that 75 yet?
No.
I'm going to need some more, right? So how many more 2s could I try? How many more groups of 2 could I try? I'll add it to the 20. So we just keep building up as we get closer to 75. You want to do another 10?
Sure.
Let's do another 10. If we do that, we have another 20. Total together now is 40. Are we at 75 yet?
No.
Not quite. So I have 20 2s. Why don't we try another 10 2s to get to another 20?
Okay.
We do that. How many do we have? Are we at 75?
No.
How many do we have so far?
30.
Is this 30? we have 30 groups of 2. You're absolutely right. But what is our total?
60.
No, we're not at 75 yet. So how many more 2s can we add?
None.
We can't add any more 2s to 60 to get to 75? Maybe we don't add groups of 10, but maybe we add a smaller number of groups, right? Let's try 5, okay? 2 times 5 is 10, so we're at 70. How many more 2s could we add?
2.
2. If we do that, we have 20, 40, 60, 70, 4. Now we can't add any more 2s, right? So how many more do we need to add to get to 75?
1 more.
1 more. I'm going to put that right over there. 1 out of that last group of 2. Now, how many 2s did we combine together to get close to 75? Let's count. 10, 20, 30, 35, and 37. So 37 and a half. What this means is 2 times 35 plus, I got to get rid of my smiley face here. Sorry, pal. Plus 1, I'm sorry, 37, right over here. Thank you. 2 times 37 plus 1 is 75. Now, let's go ahead and go back to our long division box here. How many times can we get 2 into 7?
2.
That'll get us to 4. Can we fit any more 2s in to get close to 7?
3.
3. Go ahead. Because 2 times 3,
Is 6.
so we'll go ahead and put the 6 down. And we'll subtract to get us to 1. Now we can bring that extra group of 1s down. How many 2s can we fit into 15?
10.
2 times 10 would get us to 20. That would be too much. Maybe we can try counting up to see when we get close, right? How many 2s before we go over 15? 2, 4, 6,
6,
8,
8,
10, 12, 14. Can I do any more?
No.
Don't stop. Okay, she said stop. So how many groups of 2 did I get to get close?
7.
7, okay? So we'll do 2 times 7. We counted with my fingers, and that got us to 14. We'll subtract, and that will give us a remainder of 1. So 1 out of 2. Why don't you go ahead and represent it as a fraction this time next to our quotient here. So 37 and 1/2. Give that a big I did all this work circle here to prove that our answer is strong and valid. 37 and a half. These 2 are connected. We're doing the same thing. We're trying to find out ways to make sense of the smaller group with multiples and then add that little leftover to get to our end piece. Nicely done.
There you go. And for that great work, you'll be receiving a meal of your choice,
Look out.
courtesy of our friends at Grill & Burger. So congratulations on that. Hopefully you have an opportunity to go down and try one of the many great items on their menu. We have phone tutors available until 5:30. We'll be back
Get
with
you
more
next time.
right after this. Today we're at Pond School, home of the Eagles, and we're here to And we're back at Pond School. We have some 7th and 8th grade students working with tangrams, looking at the different shapes, what they can make out of them, make the square once again. But now they have a certain task they need to work on. So you, young man, will work all by yourself because we have every confidence that you can do this all by yourself. The rest of you are going to work in pairs. So go ahead and open up the bag, take out the pieces, and you'll see one that's a little bit bigger, and those are the items that we want you to make, all right? So you can see there are 8 different things listed on there, all right? So out of the 8, here's what I want you to do. You and the person you're working with, or if you have decided to take this on your own, I want you to solve any one of them. Okay, there's also a bonus down there, but see if you can work on one of the other 8. If you want to do the bonus one and try that, go ahead. So in the bag, you have another tangram, correct? Right? Those are the same pieces you've been working with. But what's different about these pieces?
They have money on them.
They have money on them, right? Now, you guys all know the value of money, correct? Yes. So what are some of the values on here?
Pennies, nickels.
Right. They're mostly pennies and nickels, I think, right?
Yeah.
Are there any dimes?
I don't see any.
Any quarters?
No.
Any half dollars?
No.
Any silver dollars?
No.
So they're pennies and nickels, right? So very simple, okay? So for an example, let's take a look at number 1. Right, go ahead and read number 1.
Use 2 pieces to create a square worth 9 cents.
So you can only use 2 pieces, but it must make a square and it must equal 9 cents. So go ahead, try some of them, see how many of them you can make, right? If you get one, let me know and we'll see if you've got it, all right?
Got one.
You've got one? Which one?
4 pennies and 1 nickel.
Okay, so you've got number 1, 2 pieces to make a square worth 9 cents. Good. Do another one. There you go. So you've got that one. All right. Keep going. See if you guys can make all of the different tangrams.
These 3 pieces create a 6 is 5 square. That's another nickel.
Okay, so you've got 3 pieces, right?
To create triangle. No, well, I was close.
Okay, so you've got 3 pieces, right?
Yeah, but I was close.
So you went over
It's
on
all,
the.
yeah, it's 15 I meant.
That's 15 cents? Is there anything with 3 with 15?
There's 16, but
16 and 12. All right, keep working.
Oh, got it. I'm 5. Yeah. Nope.
All right, so the kids are working on making money tangrams. Most of them have found number 1. They have found number 3 where they can make a rectangle. See, now the key with this is to make sure it adds up to the correct number of cents also, right? Okay? Because you can make the shape with the number of pieces, but the bonus is to make sure it has the correct value inside of those pieces.
This is 8 cents. 2 more. Get this, but it's asking for this one, right? 8, 9, 10. This is a triangle. 2 pieces. Yeah. Smart. We found one.
You found one?
Yes. Number 2.
Triangle.
2 pieces to
worth
create
10
a
cents.
triangle worth 10 cents.
So 2 pieces to create a triangle worth 10 cents. There you go. Keep it going. All right. And those are the students at Pond School in 7th and 8th grade working with tans and making tangrams and finding the correct value. All right, a big thanks to all the staff and students at Pond School. We had a great time visiting those students. We do have phone tutors available until 5:30. We've got Jaidenelle in studio, but right now we have another opportunity to go out and visit with Marylou.
We are back live at Loudon Elementary, the ACES After School program, and we have been working on lots of math today. We were just finishing up with variables, and now we've already jumped into geometry, and we're talking area and perimeter. Okay, so everybody, we gave them this problem, and they need to find 2 things, the area and the perimeter. So, Catalina, I'm gonna have you come on up here, bring up your pen, and help us find the area and the perimeter of this figure. Because I'm looking around and I'm seeing a lot of people using different strategies. Over here I see students doing the squares for the square units. I see people over here multiplying. Catalina, can you help us out on how to solve this?
Well, 10, well, I probably wouldn't want to do all the squares because I'd probably be a kind of a lot. So I decided that instead of doing all those lines, I would multiply 7 times 10, and I got 70
Okay, remember, don't forget your square units
square units.
for our area. Okay, now, what about perimeter?
Well, the perimeter would be, well, firstly, the 7 would go here, and then there would be a 10 over here. So 7 plus 7, 14, 10 plus 10, that would be 20. Oh, 34.
There you go. So therefore, our perimeter is
34.
34 units. Write units for me. Okay, so we know what area is. We know what perimeter is. Remember, perimeter is running around the outside like we're doing in track, right? We run the perimeter. And area is the inside. Okay, that's what we need to do today. Thank you. Ready for our fun project? Erase your boards. So, this is what we're going to do. We need to know area. Who likes robots? I like robots. They're fun, huh? We're going to create a robot. We're going to create a robot. That's what our graph paper is for. But before we do this, we have to make a plan. Now, your robot, and write this, get your pens ready because you got to write those directions on your whiteboard, on the whiteboard. You can have no more than 100 square units, right? 100 on your board. So the total units of your robot has to be 100 square units, okay? Your robot needs to include a what? A head. You got to have a head on your robot. Your robot has to have some arms, 2 arms, please. Your robot's got to have a middle body part, okay? Body, I'm going to say a body. And your robot has to have 2 legs. You can add others, things if you want. If you want to add a hat, if you want to add, okay? However, you can only use 2 shapes for your robot. You can only use rectangles or squares. So what you are going to do on your whiteboard is you are going to think of the area, the square units. How many square units do you want to make for the head? How many square units do you want to make for each arm? How many square units do you want to make for the body? How many square units do you want to make for the legs? And remember, it all has to total what? 100. 100. We can't go over 100. We can't go under 100. So on your whiteboard, I want you to make a plan. Like, I might want to make my head a long rectangular shape. So I might want to make my head out of maybe 6 square units. Okay? I'm making a plan. I'm thinking it through. Maybe my arms. I don't know. Maybe I want to do my arms 4 square units each. So if I have them each, how many total units will I have for my arms? How many square units? 8. I would have 8, okay? And then I would continue on making my plan. And remember, all these numbers have to equal what again? 100. So when you have your plan done, then you're going to take your graph paper, and then you get to go ahead and draw that out on your graph paper and shade in all those fun boxes. Outline it and shade it in. Design your robot. Okay? Do you think you might need to look at the graph paper to think it out? Yes? Okay, get thinking. Any questions?
Does the face need, does the eyes or mouth need
You can
any
add those
perimeter?
after. Yes. You could be creative and add those after.
Like, does it need any perimeter or
No.
area inside?
No, it does not. You could consider that part of it. Okay? So get working and do your plan. So while they're busy working and planning out what their robot's going to look like, we're going to send it back to the studio. And when we come back, you guys are going to get to see what our robots look like. So back to you guys at the studio.
Ah, the anticipation of what they will come out to look like. We'll visit Marylou and the kids in just a little bit. Jaidenelle's in studio, and one of the other items that she's been working on in school are fractions. So you're going to multiply some right now. So take it away, young lady.
And me, right? Like
Yeah.
All
But to focus on the young
To
lady.
clarify. So when we talk about multiplying anything, it could be decimals, it could be fractions, it could be cheeseburgers, we repeat addition. So we're adding the same value a certain number of times. So at first it may be intimidating to look at something like 5 times 15/18. And that fraction alone has a lot to it. But before we get to that, let's really think about what this represents. And we were talking about this during the break. 5 times 15/18 means we can do what to 15/18?
We can add 15/18 5 times.
So we are going to add that fraction 5 times. There's something to keep in mind when we add fractions, especially since they all have the same denominator. Do we need to add the denominators when we add or subtract fractions
No,
with like
they stay the
denominators?
same.
So that's great because we know right away our denominator is going to have an 18. Awesome. These 15s, what can we do with those?
We can add them.
We can add them. What is your preferred method for adding all those 15s together? Do you like to line them up? Do you like to skip count? What do you prefer to do?
I like to line them up.
Let's line them up. So we're going to have 5 1s, and we're going to have 5 5s. As I say that out loud, I kind of realize I can do something with this, right? If we have 5 1s, well, these aren't really 5 1s. These 1s each represent a 10. So if I have 5 10s, how many do I have?
You have 50 10.
So I have 50. You're right. And over here I have 5 1s, column values, and they're each 5. So I have 5 5s. So if I have 5 5s, how much does that equal?
25.
25. So I have 50 plus 25 by adding just the place values. 50 plus 25?
75.
75/18. There are many in this world that believe that this is not done until you turn it into a mixed number. Or there would be those that dare call this fraction improper, which sounds so impolite, like it broke some rules of manner and we're to be offended by it. This is an exact value that represents the solution to this repeated addition, to this multiplication. I think that there is nothing wrong with this value here. But there are easier values that we can make sense of how much this really is. And so let's think about 5 times 15/18 again. Because we mentioned the complexity of dealing with those larger numbers. But the funny thing about a fraction like this is it can look a lot of different ways. There are equivalents that we can multiply up. This is the same value as 30 over 36. There are any number of equivalent values, but we can also find simpler and reduced forms of this. Is there something else we can do with 15 over 18 to make it maybe a little easier to work with?
We can.
So she may not have simplified yet in 4th grade.
So here's what we can consider. 15 over 18ths. If I have a rectangle that is broken up into 18 parts, and 15 of them are colored in, that represents a part of the whole that we have colored in. But there are other ways in which we can represent the same part filled in. If we start taking some of these lines away, let's say this one, well, let's say maybe this one here. I have so many lines I drew. Then we realize that this is broken up into smaller pieces here. So I have 1, 2, and one more of these that are filled in. But I also can remove some of these lines across. So if I think about this fraction, is there something that both of these have in common that I could divide both of them by? is there a number that goes into both 15 and 18 that I might be able to simplify this by?
3?
3. So if I divide 15 by 3, I get 5. If I divide 18 by 3, I get 6. Both of these fractions are equivalent. They have the same value. So if these have the same value, why don't I multiply with that one instead? Because I'll end up getting the same value, right? So let's try that. Let's try multiplying 5 times 2 thirds. Now you mentioned something over the break too, that we don't necessarily have to treat this just like a 5. We could represent this as something else. How else could we write 5? There's something you said you put under that 5?
We can put a 1.
So 5 is the same thing as 5 whole, or 5 over 1. And there's something very unique about being able to multiply with fractions. You remember how we said we could not add the denominators? What happens with multiplication? What are we able to do?
Multiply
We can multiply straight across. So 5 times 2,
is 10.
1 times 3,
Is 3.
10 thirds. Some might call this improper, but I think you're fine just the way you are. Let's get back here to 7518. We said that if there was a number that you could divide both of these by, that you could represent that same fraction a little bit differently. So is there something that we can divide into both 18 and 75?
7?
Well, I don't know if we can divide 18 by 7. But if we're ever tasked with this question, there's an interesting trick we can employ. We know that if two numbers are even, we can divide them both by 2, right? Every even number that ends in 2, 4, 6, 8, 0, we can divide it by 2. Here's a way that you can tell, and this is for everybody watching us, that you can divide a number by 3. Add the digits of your value together. So for example, for 18, I add 1 plus 8, and that equals 9. Can I divide 9 by 3?
Yes.
If I add 7 plus 5, I'll get 12. Can I divide 12 by 3?
Yes.
So I can divide both of these by 3. If I do that, I end up with 25 over 6. And I believe I need to go back to something here.
Right, because the 2 thirds you took from 5/6, it
So
should have
that's
just
not
stayed
really-
5/6.
Right, we
You were
multiply
thinking
by 2
4/6.
thirds. So let's go back to that and let's do a little bit of revisitation here. This is why it's really good to have 2 different ways of doing the same problem, because we didn't want to settle for this. Let's look at this again. This is really 5/6. So let's remultiply. That part I think we had down pretty well. 5 times 5
25.
and 1 times 6.
6.
Now let's get back over here. We divided 18 by 3 and got 6. We divided 75 by 3 and got 25/6. Do the 2 methods we use line up
Yes.
and get us the same thing? There are always different pathways that will bring us to the same place. And even if one of them brings us off to the distance, that other way will bring us right back to where we need to be. And I think that's a great example of the work we did to make sense of that. Thank you for working with us on that.
Nicely
Great
done.
job.
Moving on, erase that. I need a rectangle up there.
Let's make rectangles.
And I need it measured 10 by 7.
Okay, we're going to do a 10 by 7 rectangle here. Hey, this looks a lot like the rectangle we had before with Marylou, huh? This is not to scale, but we're going to play pretend on this one. Here we go.
And Jaidenelle, when we were doing the area, when Marylou was doing the area of a 10 by 7 rectangle with the kids over there, what was the area of that? Do you remember? Or can you figure it out now?
I can figure it.
What is it?
34?
Well, that was the perimeter, right? Going all the way around it. So now we want the area inside of it. So you're going to go length times width. So what 2 numbers do we have to multiply?
10 and 7.
And what is that going to give us?
70.
70, right? So we have 70 square units. Now, what I would like you two to do in, let's say, 2 minutes, if you can.
Well,
We know that, now it's important that you said 34, let's just make this feet.
okay.
Okay, so we have 34 feet of fencing. All right? You have to use the 34 feet, but I want a larger area. using the 34 feet. How can you make a larger area using the 34 feet? You've
So
got 2 minutes.
what this means is we're not going to have the same rectangle. We need different dimensions. So let's get rid of these squares. We're done with them. We need something else instead. So we have 34 feet of fencing, but it's got to be a rectangle. So how can we create a rectangle that has a perimeter of 34 with a larger area than 70? We may have to try something just to have a reference point. So how long or how tall can this rectangle be? What could we try?
3 and 7.
3 and 7. Now, maybe we start off with each of these sides here. If we have 3, that's going to get us 2 sides that equal 6. But we have a perimeter of 34. And if we have 6 used, that means we still have 28 feet left. If we're going to have 28 feet left, we divide that by 2, so we have 2 equal groups. We're going to need 14 on each side. That's going to get us a perimeter of 34. But we need to find out if the area is going to be larger than 70. So how can we find out what that area is?
We can multiply 14 by 3.
All right, if we do 14 by 3, we're going to have 4 groups of 3. That's 12 with a 1 down here. 3 plus 4. That gets us 42. Is that greater than 70?
No.
So we got to try something else. What else could you try?
So you're on the right track because 10 and 7 equal up to 17. 14 and 3 add up to 17. So you want 2 numbers that will add up to 17, but will get you larger than 70 when you multiply them. So those 2 numbers are pretty far apart, 14 and 3. Try to get closer together. That's my clue.
Okay.
So what else could we try as our perimeter sides here?
We could try 11 and 9.
11 and 9. Now, does that get us equal to 17?
No.
Not quite. So what can we try instead of 11 and 9 that get us closer? Because 10 and 7 are pretty close. What are the 2 numbers that are closer together might equal 17?
Six and 11.
6 and 11. Are they closer together on a number line than 10 and 7 are? We can try it. 6 and 11. If we multiply them together, what do we get?
We get 66.
So is that bigger than 70?
No.
No, but it's close. We had 6 and 11.
You have one more
We
option.
had 10 and 7. What 2 numbers closer together, when we add them up, equals 17? We can even look at this on a
Think
number
about
line.
after 7.
So these 2 equal 17. These 2 equal 17. What other 2 numbers could equal 17 as their sum?
8 and 9.
8 and 9. Fascinating. Let's try that. 8 and 9. So we have 8 and we have 9. If we multiply 8 and 9 together, what is their
That's
area?
72.
72. Is that greater than 70?
Yes.
There you
Let's
go.
do it.
Nicely
We
done.
nailed it.
Got it right at the buzzer. There you go. 8 times 9. All right, we do have one final opportunity to go visit with Marylou, see how the robots are coming along.
We are back live at Loudon Elementary, ACE's after school program, and we have been so busy building our robots. They have been thinking and thinking, and they've been erasing and redoing. First, can you kind of quickly tell us, what was your thought process? How are you been doing here?
I decided to put 3 units as the feet, 4 units as the legs, and 36 units as the body, 10 units for the hat, and 7 per arm.
Okay, so I see you're starting out, right? Have you had to make any adjustments?
Yes. The arms I had to make adjustments, and the legs.
Okay, did you have to make them longer, shorter?
Some of them I had to make longer, like the hands, so I could have more numbers and
Okay.
units.
And you're not quite at 100 yet, are you? Okay, keep working, keep working. We're gonna go over here, and if you look at these boards are amazing. Your guys' thought process, you brainstorming some ideas. Can you kind of tell us what your plan was here?
So I plan to make a robot and have her hair and her shirt like kind of like a princessy, normal. And then I decided to make her boots because I thought it would be creative to do something like other than like the robot's head and body. I decided to do the boots.
So you want to be a little bit more creative. Now, earlier when I came by, you didn't have quite 100. You only had 64. So what did you do to your robot to increase it to get it to 100?
I added.
What did you add?
So I added these two because it wasn't really quite 100. All I needed was 2 more, and then I got 100.
And you got it. Oh, you at 100 now. Okay, and I think her hair got bigger too. Yeah. Okay, this group, you guys are doing a great job on your whiteboard. Let's go over here. Now, did anybody in this group get 100? You got 100. So tell us what you did.
Well, right here, it was, so I times it by 5 and 4.
So how many square units do you have for the head?
For the head?
Uh-huh.
For the head, I have 45. I mean, the 25, and the body is 45, and the hands are 6 right there, and my legs are 24.
Okay, and your legs are a total of 24 to get 100. Did you want to add anything else to it, like to decorate it up or anything, or are you good?
I'm good.
Okay, what did you think of the whole process?
Oh, okay. Yeah.
Yeah?
Yeah.
Did you find things where you had to adjust anything?
Oh, yeah. My legs.
Okay, what did you have to do? Make them shorter, longer?
Longer.
Okay. Well, we're going to go over here to your partner because you went over, didn't you?
Yes.
What number did you come up with?
107.
So what did you have to take off then?
I had to take, so I originally had an extra layer of for the body, but then I took off 1 layer, and then I had 102, so then I had to take off this little cube to make him have little fingers, and then that's when I got 100.
Well, that's looking awesome. You going to do any decorations on that? Okay, let's go over here because this group right here, their whiteboards are really, your brainstorming is amazing. Did you end up with 100 yet?
Yes, I have.
Can you tell us exactly from starting to finish, what did you do?
I tried doing this, and then I figured out that this wasn't in 100, so I added these decorations, and then I kind of extended the feet a little bit, and then I added all of my things together, and I got 100.
You got 100. And I love your little design. It's really creative. And over here, your designs have been really intense, and I noticed that you brainstormed a lot on your whiteboard. Can you tell us real quickly what you did?
At first I started off with the plain body, hands on the side, then I realized it would be more creative to put your hands going out to the other side, and I thought it would also be creative to add some shoes and details to it instead of it just being a box.
Wow. Well, you guys, I want to thank everybody today here at Loudon and the ACES After School program. You guys have been wonderful, and I'm going to let you guys finish up your robot, but that's it from us here at Loudon. We'll send it back to the studio.
All right, nice to see all of the leopards at Loudon Elementary doing some great work. Lovely robots they had. Thank you to Marylou for visiting out there. We do have phone tutors available until 5:30 this afternoon. We would like to say thank you to our guest, Jaidenelle. Did you have fun today?
Yeah.
That was pretty good, wasn't it? You did a lot of work while you were in here. So that means we are going to award you with a uniform. You have to wear that every day now. You good? Almost every
Good
day.
color, right? Yeah.
Hey, you know what? Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Kern Schools Federal Credit Union, California Resources Corporation, Bakersfield West Rotary Stroop Family Foundation, Panama Buena Vista Union School District, Bakersfield City School District, and the Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.